this is assume that this is a smooth surface and an object of mass m is placed on it. So a force F Newton is applied to this object. So what will happen? This object will move in the direction of the force. Okay. So basically a work is done by this force to move this object from point A to point B, which is at a distance s meters. Okay. So s meters are moved by this force in the direction of the force F, because surface is parallel to the force is parallel to the surface. So it has moved along the surface to this point B. Okay. So now what is the force? What is the work done? Work done will be force F displace the object of mass m s meters from A to B. So the work done by the force F will be force times the distance. So the force which we apply to the object times the distance the force moved this object from A to B. So it means that it will be F times S, because the force is F and the distance moved is S. Here the entire force F is doing work because F is acting in the direction of motion, parallel to the direction of motion. Okay. So since it is in the same direction of motion, so we can say this is the work done by this force. So the word by is important here. Sometimes it will be against the force F, and in this case it is by the force F, because force is in the same direction as the object is moving. Okay. So this concept is clear, that force is equal to, work is equal to force times distance. Right?
Yes.
So here now we will talk about the units. So since work is equal to force times distance, and force is Newton and distance is meters. So it means that in SI system of units, it will be Newton meter, which is called the joule. Newton meter is joule with capital letter J. As you know that if the unit name is with some of the mathematician or scientist's name, so then the unit will be in capital letters like Newton, watt, joule. That is capital. All other are small letters, like meter is small m, second is small s, acceleration is small a. Okay. So bigger units of this is kilojoules, kJ, which means 1000 joules. So the unit is joule, or we can say Newton meter. So now if the force is acting at some angle, so this red one is the force which is acting at some angle, and this angle is with the surface. Okay. So in that case, the whole force F will not do the work. Some part of the force will do the work. Like that force, since when this force is applied, the object is be dragged on the surface. That means that this blue component, which is F cosine theta, is working. F sine theta, which is perpendicular to the direction of motion, is not doing any work. Okay. So that's why in this case, the work done will be the force, which is F cos theta, times the distance it moved. Formula is same, but only difference is that the whole force F is not doing work. Only the component of force, which is F cos theta, is doing work. In this case, the work done by the force F will be force times distance. So it will be F cos theta times S. Okay, and this is also the work done by the force. Okay, because it is in the direction of motion. The force component is in the direction of motion. So this is the second concept. First concept, that if the force is acting in the direction of motion, so then the whole force times the distance, F times S. Second is that when it is having some angle with the direction of motion, so the component of the force which is in the direction of motion, that multiplied by the distance. Two concepts. Okay, then the third concept is that if surface is not smooth, it is some rough surface, so definitely there will be some friction there. So in that case, if the friction force is Fr, so to bring this object from point A to B, some other force will do the work. Like we need a force here which will move this object. Some force we need here. And to bring it from point A to B with a uniform speed, we will apply a force equal to the force of friction. Like a force needed to bring it from point A to B with a uniform speed, we need an equal and opposite force which will bring it uniformly to this point B. So it means this force F is doing work against this resistive force. Okay, so that's why in this case we will say that the work done is against the friction force, but it is by the force F. So, but since F is equal to Fr, so that's why the work done is F times S. But since we know that F is equal to Fr, so it means that the work done will be resistive force times the distance. But it will be the work done against the friction. So whenever the force is opposite to the direction of motion, so then we'll say it is the work done against that friction, against that force. Okay, but mathematically the value will be same. Either it is F times S or it is Fr times S, force of resistance. So we can say that the work done against the friction Fr or against the resistive force Fr, that will be equal to Fr times S. Okay.
So Fr is the friction.
Sorry? Yeah, Fr is the friction. It is actually a general resistive force. So that resistive force may be a friction force or maybe an air resistance. So Fr is friction we are taking in this case. Okay, so we are not doing any net force acting to the object. Sorry, net work done on the object. We are finding the work done by or against some single particular force. So in the first case, it was a friction force. Sorry, there was a force F, which was acting in the direction of motion. So then we simply said that this force times the distance moved. Then in this case, we have a force which is resisting the motion. So this is a resistive force. So we are basically finding what is the work done by some force against this friction. So then we will simply say, we will not consider that force. We will only take this force times the distance moved. And this will be against that force Fr, and this will be by that force R, or that by force F. Is it clear? And the third thing which we have considered is that when the force is acting at some angle. So force is acting at this angle, so that one, if it is acting here and this angle is theta, so then the component of this force is doing work, the whole force is not doing work. So here is the force F cos theta. So it means that the work done will be F cosine theta times the distance moved S. So this is the work done by the force F. So any force which is perpendicular to the direction of motion is not doing any work. Like there are many forces here. One is the normal contact force, one is the weight, and similarly in this case there is another force which is F sine theta. If in the question it is asked that what is the work done by F sine theta, so that will be 0 because there is no distance covered vertically. That's why F sine theta is doing 0 joule work. And can you tell me what is, in this situation when it is moved from point A to B, what is the work done by the normal contact force? Object moved from here to here. So what is the work done by R? Yes, any student?
Sir, you said R is perpendicular. It's not.
Yes. So the answer will be 0. So work done by the normal contact force R, that will be equal to the force multiplied by the distance. So no distance is moved in the direction of R, in the opposite direction of R. So then this will be 0. So it means the answer is 0. Similarly, the work done by the weight. No motion, vertical motion is here, so it means no vertical distance is covered. So it means this is the force times the distance 0, so the work done is 0. Okay.
Sir, can you please repeat that point? I didn't understand it.
See, basically the work is always the component of the force which is in the direction of motion or opposite to the direction of motion times the distance moved. So the object moved from point A to B. This object is moved from here to here. Okay. So the work done by R will be the force R times the distance moved in the direction of R or opposite to the direction of R. Since vertically there is no distance covered, so it means that the work done by the force R will be equal to R times 0. It will not be R times S because R is not acting parallel to the plane. So that's why it is 0. Clear?
Yes, thank you.
And similarly for the weight. Weight is also perpendicular to the direction of motion. So it means the work done by the weight will also be 0. So sometimes we use the term gravity instead of the weight, especially in physics. So we say work done by gravity is 0 in this case. Okay, so now the next part is, this is an object placed on this surface and we know that the weight of the object is acting vertically down. So this object is brought from this point to some point vertically up. So it has moved each meter from point A to B upwards like this. So obviously it will be done by some other force. So we'll use the term that the work done by some other force against this weight, against the gravity. So that will be equal to, from point A to B at a distance h, I dash it has moved. So the work done by the weight will be, against the weight will be the force, which is the weight, times the distance, which is h. So it will be W times h. Okay. The same concept that the work done against the force is force times the distance moved. So force case which we are doing work is W, so W times h. And we know that W is mg, so in detailed we can say that it is mgh. And we know that later we will do energy, so we will see that this is mgh is the change, is the kinetic energy of the object when it is at the point B. So later we will correlate between the work and the energy. And we will form another equation which is called work energy equation. But today we are doing only the work done by a force are against a force. Okay,
so isn't mgh gravitational potential energy?
Yeah, this is that thing I'm saying. It's the gravitational potential energy, or simply we call it potential energy. Because in mechanics syllabus, we don't have any other potential energy in the syllabus. So we say it's simply the potential energy. Okay, so this is also the potential energy, PE. But we'll talk about this later. Here we are doing only by that what is the work done against the gravity or against the weight. So that is weight times the distance, h. Okay. So this work done is called the potential energy in the object. So when it is at the point B, it has the potential energy, and that is equal to W times H, or you can say mgh. That's why if you release this object from here, it will fall down and it will hit the ground because it has a potential energy. So that energy will do some work from point B to A. But if this object is at the ground and if you release it, it will not move because here mgh means h is 0 when it is here. So at this point h is equal to 0. So it means what is the potential energy? It will be mgh, so it will be 0. Okay. But we will talk about this in detail in our next lesson. So we are doing only the work done. So potential energy is equal to. So this is the definition of the energy. The ability to do the work is called energy. Because at point P it is able to do a work, so it will fall down. That is the work done by that. But it is at the point A, it has no ability because it has no energy to do the work. That's why if you release it at. Okay, so this one, this summary is involving something more that we will do next time. So work done by the force is Fs. Work done against the friction is Ff or Fr times S, friction force times S. That is the work done against. And work done against the gravity is mgh, and the potential energy PE is also mgh. So these things we have done. Okay. Okay, now going to the